Hello and welcome to this SOFiSTiK tutorial about the cross-member command in the SOFiSTiK Bridge and Infrastructure Modeler. In this tutorial, I want to show you how to create a diagonal beam in Revit. The basis for the diagonal beam are two adaptive points, a start and an end point for the created family. These points are located longitudinally to the axis. This means we can, for example, manipulate the height development of the start and end point of our diagonal beam separately along the development of our axis stationing, in this case in a 5 meters interval. There are multiple ways to achieve these kind of developments along the axis stationing based on the adaptive points. The first one that I will show you is how to read the length between the inserted points of the final family and the height development based on a variable. This way we can calculate the angle in between those 2 points for a perfect cutoff of our diagonal beam. The second method that I want to show you is also reading the length in between those two adaptive points, but this time the height development is based on a shape handle point. This shape handle point allows the family to read the height development parametrically from a secondary axis that is defined in your main project. Let's start by creating a new project in Revit. So I select the standard construction template and I move over to a 3D view to directly create a new axis with the SOFiSTiK Bridge and Infrastructure Modeler. So I click on Axis, Create, and the standard settings are fine. Now what I want to do is I want to add a secondary axis to this main axis. To do so, I select it, edit the axis and go to secondary axis. In here you simply can select secondary axis and this is going to be the axis to the right of the main axis. You have the options to select a horizontal and vertical offset, and to simplify the offset, I get rid of station number 30 and 90 and set the value of the offset to minus 5,000, which is 5 meters in the beginning, as well as the end. This now creates this little red line, which has the direct offset from the axis itself with 5 meters. This is going to be our reference for the longitudinal beams that we will create. Additionally, I want to create a variation for this axis, meaning a variable that I want to add. To do so, I once more select the main axis, modify it, and create a variable. I will call this variable h for height. In this case, I want my station at 0 to have a value of 3000, at station 35,000, so at 35 meters, I want it to be 8 meters, so 8,000, and at station 85, I want it to also be 8 meters, and at 150, I want it to be 3 meters once more. And in between, be careful with the digits. So as we're working in millimeter, in between, I want an additional station at 60 meters that will have a value of 4. By the way, you can always change the stationing values where these variables are going to be defined. So for example, I can come here and change this value of 3000 from 150 meters to 120 meters, and it will be updated immediately. By the way, be careful, 60,000 of course, and 4,000 as a value. You can see that the transition of the values is polygonal at the certain points. I want this to be changed to have high points at these middle stations, meaning a transition left to right. And this will give me a geometry like that with the certain assigned values, which are lengths. So this is going to be the height development of our beam along the axis. So far so good. Now it's time to actually create the corresponding family. To do so, I start a new family via metric generic model adaptive. Remember, we always work from left to right, and this time we not only want one adaptive point, this time we want two. I start by creating two reference points and align them to the origin coordinate system of my reference plane. I can simply select both of them and click on Make Adaptive. Just to show the principle, I will quickly create a random longitudinal beam. So this is not something you necessarily need to follow along, just listen for this part. So I set the proper reference plane to draw a reference geometry, in this case just a simple rectangle. I do the same thing for the end, and the program will now allow me, once I click on Is Reference Line, to create a form out of them. So a simple form, and you can see if I move the adaptive points, the geometry will change accordingly. I will quickly save this example. I will call it our diagonal beam because I will reuse this name later on. So you can actually do this step and save this example as diagonal beam. And I want to load it into my project. When I create a cross member now, based on my secondary axis, and I simply leave it at the placements, the program will create these beams with two adaptive points from the first definition to the second one, from the second to the third, and so on. So it is necessary to define from which placement to which placement these beams will be created. And in our case, it will be enough to have them from station 30 to 90 with an additional interval of beams in the middle. And you can see when I set it to 2.5 meters, the aligned geometries are 2.5 meters long and in an interval between my two main placements. So that's the principle that we will use, and we will add additional functionality to the family now. So I move back over to the family where I created our rectangle, and I get rid of all the references I created. Because you remember, we actually not only want to have a longitudinal beam along our axis, we also want it to be diagonal, meaning with additional height information. To do so, we have to think about what's necessary to properly create this, meaning we first up need an additional point for the height. So at the end of our beam, I want to create a height variation. So I create a new reference point right here and give it a specific value like 3000. This we want to control via our variable later on, meaning that now we will start creating parameters. First up, for our height, which is going to be an instance parameter of the type length. And we can assign it directly to our reference point by clicking the little rectangle next to the value we assigned. And in this case, I select height. It has a value of 0. So if we come back to our input and we change the value to 4000, the program will update the aligned geometry. Now keep in mind that every reference point, so the same as every adaptive point, has its own coordinate system, and everything, by the way, you can show it by show reference planes, and everything we actually create in these aligned reference planes will always be aligned like that. So in our case, when we do want to create a diagonal beam, it would not be feasible to simply create a start and end rectangle as I just did it for my test beam, because it will always be vertical. But what we actually want our geometry to do is to rotate around this point exactly to get the proper diameter of the cross section that we create. Meaning that we somehow have to rotate the end point. This can be simply done by rotating along this point with the right reference plane. To do so, I set this reference plane, which is actually cutting through the start and end point, and create a new point in here. I get rid of the original reference planes, and you remember the last element that was created is first selected by Revit. So here you can once more check there is no offset, there is no rotation or anything visible, and I now showed these reference planes of this point. And now the variable that we want to use is the rotation angle. So you can see as soon as I assign a value to it, it actually rotates the whole reference point. This is what we will use to align our rectangle. What do we need to calculate it properly? We need the length of our element, which you remember is going to vary depending on what interval we assign to it, and also the height information. The height information is already available through the value that we assigned to our height here. So let's actually create the parameter which will read the distance in between our two adaptive points. To create it, we need to set a horizontal plane, for example for our starting adaptive point, and we need to create a dimension line. When you now select this dimension line, up here you will find the label dimension. If you click on create new parameter, it will open up the same interface as by creating it directly in the properties, and this is going to be our read length. This is now going to be an instance parameter, but this time a reporting parameter. Meaning that now it will always read the distance in between those points in our main system as well, and we can do operations with other variables in this family. So I come back to my properties and I add a new parameter, which I will call angle. This angle parameter will be an instance parameter, but now not a length, but a rotation angle. Click on OK. And now it's just a matter of creating the right formula for this system. In this case, I already know that it's going to be negative arcus tangens of my height divided by read length. By the way, if you made a spelling mistake, you can always come back and modify your parameters, and they will also be changed in the corresponding formulas later on. And here you can now see the calculated value for our angle. Let's assign it to the reference point that I selected here. So simply up here in rotation angle, I select the box, select angle, and it immediately aligns properly to our reference of the starting point. To create a properly clean geometry, we need the first point to rotate as well as our end point to rotate, meaning that we need a new reference point down here in this plane. I select it, create a new reference point, and I click on it and assign the same angle. You can see that the reference plane of our original adaptive point is still visible. We can simply make it invisible, select our reference point, and we show the reference plane of this point. Now it's just a matter of creating the geometry accordingly. So we need a couple of new parameters. The first one is going to be the width of our cross section. It's going to be an instance parameter. I will select this one, copy it, and it's going to be the height of my cross section. Simply because of the alignment of the coordinate system of my point, I need half values for these cross-section values as well as their negatives. To do so, I will just create half height first because we need the negative half height. So I select half height, copy this one, call it negative half height, and I do the same thing for the width. So I call it W, and the same for the negative half width. Now I simply have to assign the proper variables with their operations. So I go to width cross section, and for half width cross section I divide it by 2. And the negative half width is going to be negative half cross section width. I do the same thing for the height of the cross section. Divide it by 2. And I select the negative. These values will not be accessible by the user anyway. If you want it to be a little bit cleaner in your family itself, you can simply group it somewhere else, for example in other, and you will notice that it is with the other unused values from the direct input. Let's just check if it actually makes sense what I created here. So I input a value for the height, I also input a value for the width, and I get 200, 200, minus 200, minus 200. That is perfect. All right, now we create the cross section. To do so, I actually start at the top where I will assign the width of my section first. So I select the vertical plane. I create 2 reference points, and the first one gets, by the way, here it might make sense to tab once, use tab once. And I want to assign an offset, which is going to be my half width. Second one is going to be negative half width. By the way, if you're not sure if you selected the right point, check if there is an offset or a rotation angle selected. If there is none, you got the right point. Now it's just the height that we still have to assign here to create our parametric rectangle. So I select this plane, create a point, select this plane, create a point. Actually, I can already create 2 points at both planes because 2 of them are going to be vertical, 2 are going to be positive, 2 are going to be negative. By clicking Control, I select multiples and I assign half height as well as negative half height. I selected 1 point twice. Be careful. And I assigned it to the wrong plane. Oh, be careful to not go too quick. So you saw that this one was dependent on the wrong point. So all the points are always dependent on each other. All right, what's the goal we want to achieve? I simply select the corners, 2 of them, create a line, select another 2, create a line, and now everything we did starts to make sense, in which we now created a parametric rectangle. You can select this rectangle. This is supposed to be a reference line once more, which is not a reference in your project, meaning that it will not highlight once you hover with your mouse over it. I now create the same rectangle on the bottom. So I will just speed through this one, select 2 points. By the way, if one of these elements is in your way or annoys you, you can temporarily hide them via the sunglasses down there. So it's easier to select, which is going to be half width. Negative half width. And now zoom in and go to the height, which is once more the plane which rotates with our original rotation point. I select two of the points I just created to be quicker, where I select half height, another two, and I select negative half height. I link them together to get my rectangle. Set the splines that I just created to is reference line with not a reference, and the first element or family that we want to create today is done. I select the start and the end reference lines and tell the program to create a solid form. If we take a look at it from the side, you can immediately see that they are perfectly aligned with the angle that is created by modifying the length of the section or of the cross member element that we create here, as well as when we change the height value, it will always be a perfect rectangular column element. Now we are ready to actually load it into the project. Before we do this, please check that you saved your diagonal beam family. Just want to override it, as well as assign a type. All right, let's load this family into the project. In my case, I want to override it because I already had an older version in here. And let's create this cross member in between our station 0. And now I want to manually create a new station because you remember our variable is created from 0 to 120. So I select a new station at 120 or a temporary station. And I want to create my diagonal beam type 1. Here you can see a preview of the family. And let's for now just create it in an interval of 5,000 millimeters. This is the result you should get. All of these beams have the preset out of the family that we prepared beforehand, but with a 5-meter interval in their placement. Let's modify them. Let's actually assign our variable to it. And even though we are only working on a secondary axis as a basis, the main axis still has the information of h transferred to our section here. So let's see what happens once we actually apply the height. And here you can now immediately recognize what the program does, but let's actually check if the program does it the way we want it to. To do so, I want you to create another secondary axis. This time, I want it to be on the left side, which is gonna have a horizontal offset value of 5,000 and another time 5,000. This doesn't allow you to check if it's properly assigned yet. So to do it properly, we want to create one more secondary axis, specifically a secondary axis for the height. So in this case, I actually first want to start with it on the left side. So with a horizontal offset of 5,000 and another horizontal of 5,000. So it's at the same place as the secondary axis to our right already. But this time we also want to assign a vertical alignment. You could now copy the input that we created here, but you can also simply reference this variable data directly. So variables can be assigned to, for example, the height offset of your secondary axis by simply clicking on by script. And instead of the stationing value here, you set it to hashtag h, because the name of the variable is h and the hashtag assigns the variable to the script. Click on OK, and you can instantly see in the place where it's defined, it has a height value. Let's click on OK. And when we now double check, you can see that this does not match at all. Even though we perfectly defined everything, right? That is not completely true because we missed one crucial point. I always talked about a starting point. Here you can see number 1, and here is the end point with number 2, which is now placed in an interval of 5 meters. But the program does not automatically know that the point number 2 wants to read the height at the end of the cross member. This is something you have to tell the program by clicking at local station over here. So we have the variable assigned, and for this variable, we do not want to read it from the beginning of the cross member, but from the end. Once you change this, you will notice that the secondary axis that we created now perfectly aligns with our cross members. So this is our method number 1. Next up, I want to show you how to create this cross member, not depending on a variable, but on a secondary axis directly. To do so, I want you to modify your main axis and move this secondary height axis to the left side. So instead of negative 5,000 to positive 5,000. So here you can now recognize this is going to be our bottom reference and this is going to be our top reference. To get started with creating this other family, double click onto the already existing diagonal beam type 1, double click onto it, and we now want to modify this one. To do so easily, I want you to save it with a separate name. So I click on family, save it, and this is going to be diagonal beam underline sec for secondary. What do you need to consider to properly assign a secondary axis to be read at the end of your adaptive family? Select any kind of point, doesn't have to be in the plane or anything, and instead of leaving it as a reference point, you set it to a shape handle point. It is imperative to give it a name. So in this drop down here, I will call it height reference. It has to be a clear identifiable name for you because this one will be also available later in your cross member selection to be assigned to a axis. You remember this reading parameter that we assigned to our adaptive points? We can use the same functionality to read the height that this shape handle point will read later on. To do so, we simply need to assign a reading variable to the height in between our adaptive point and this shape handle point. Preferably in this case in the end of our cross member, so I select the vertical reference plane and I create a dimension line in between the two. Again, as simple as before, I have to assign a new parameter to it, which is going to be our read height parameter, instance parameter, which is going to report for us. Click on OK, and instantly you can see that this parameter reads the height in between those points. And we can use this to simply assign this height that we have here to our variable that we before were reading directly from the project. You can see as soon as this reading parameter is assigned, it shows up as a report parameter in here. And the read height parameter is defining our height for the value of the distance between our second adaptive point and our inserted diagonal beam. I click on OK, and this is actually all the adjustments you need. And you can see as soon as this shape handle point is moved, the height of the cross member is also adjusted. So let's load it into our project. And let's place the newly created cross member on our secondary axis, which you can find here, diagonal beam underline secondary axis. I select type 1. And now, instead of the height variation that it required before, it asks us for a height reference, which is in this case an axis ID. Can simply select our secondary axis here, and careful, once more it is important to assign the end of the cross member to be red, and I create my temporary placement at 120 meters, and I want it to be created in an interval of 5 meters. And instantly we get the same result as before. Now I want to show you a really neat and quick trick that you can use to vary your alignment of these diagonal beams. So to do so, or to show you quick and easy, I will actually edit the placement of my members to be very short, just to the first placement. And after this one, I want it to be turned around. To do so, I once more double click onto this diagonal beam. And all you need to do in this case is select your first adaptive point. Be careful to actually select the adaptive point. You can read down here if it's the right one. Or actually you can just select the second one and change it to be your first index of adaptive points. The second one changes automatically, of course. Save it separately as a new family with a new name. In this case, I will call it negative in the end. Load it into your project. And now when you place this new cross member, I simply click on create and I select my diagonal beam negative. I assign the height variable. In this case, I now want it to be at the start, so at the beginning. I start at station 30, go up to 120 in an interval of 5 meters. And click on OK. And here you can see changing around the numbers of the insertion point takes care of all the parametrization immediately, and you can very quickly and versatilely create complex parametric geometries.